Hello everyone. My name is Akanksha Agarwala and this is Team 2 Deliverable 8 presentation on our project called Squander. For our agenda today, we will be going over the Squander team members, then we will be discussing the project overview along with personas. Then we will be looking at the technologies used for Squander along with the design architecture. Then we will be discussing the sprint overview and the sprint recap, followed by product backlog and sprint backlog. Then we will be going over the retrospective, followed by the future sprint. Then we will be demonstrating a project demo. So, as you all of you know that our team is formed of five outstanding individuals with various backgrounds. So our machine learning engineer is Nicholas Wong, whose responsibility was to design the computer vision model architecture where he has trained and evaluated the model performance by gathering image data set for training. Then is our cloud engineer, Austin Blaze, who was responsible for for the architecture of our project, where he has created the project as an infrastructure as code by integrating different features and services. Then is our iOS developer Rajat Navgafkar, who was responsible for designing and developing the Squander application. He has integrated the machine learning model with the Squander application. Then he has also tested the application to make sure that the app is user friendly. Then is our full stack developer and the quality analyst Suryadeep Nalana, who has contributed to the design and development of the application layout along with Rajat. He was the sole person responsible for the technical document of the paper and he was testing the application regularly, making sure the app is user friendly. Then here is I am Akanksha Gurwala, who is the project manager and the scrum master of Squander. My responsibilities was to lead the team meeting and keep the team on task. I was responsible for maintaining the Squander's GitHub repository and the wiki. I also documented all test cases and also co-authored Suryadeep in writing technical paper. Next, Suryadeep will be presenting.
Project overview. Problem statement. With the vast population of people around the world, the amount of waste produced has been gradually increasing with the increase in population. On an average, the world produces 2 billion tons of urban solid waste yearly, and United States being the highest producers of waste among others. Around the world, the waste that is produced remains unprocessed due to lack of recycling knowledge with the people. Our scanner app overcomes this problem by producing a complete solution to organize and plan the disposal of waste through image recognition technology using machine learning algorithm to detect recyclable waste from images and produce proper disposable. With our app, we make people be responsible and contribute to make this world a better place. Project description. Our Squander application is an image-based waste detection mobile application. It is worked by a user submits an image to the application and a trained machine learning model runs on the image and gives results and information. The application is a simple tool to detect waste with best accuracy results and easy steps to undergo the process in the application. And one more thing, why you should use the application is it because it produces nearest recycling location along the rates and option to schedule a pickup personas. Zil, uh, Zil is a 32-year-old. He's an event organizer. Uh, he has organized many big parties. He takes all the responsibilities, such as handling the decorations of the event and catering the food. His company particularly known for the food that is served to the people with tasty and hygienic food. After the party ends, the food that is left should be trashed carefully and Sill is responsible to it. Sill can do easily with Squander application by taking the image of this his trash and finding all the information of what kind of waste that can be trashed that is found within his image, and where he can take this trash to dump and schedule a pickup of his trash from nearest recycling factory location on the application. Simon. Simon is a mechanic. His age is of 35 years. He inspects the vehicles like cars, motorcycle, light trucks that comes to his garage for a repair. His work produces a lot of metallic waste in a day that comes from repairing the vehicles, and his metallic waste can be taken by recycling companies, and Simon can make money out of it. He can contact the recycling company and have a deal using Squander app. David. David has retired from his sales executive job recently. After producing more than 30 years of his service, he was successful in his field and has been an inspiration for others. After the retirement, he wanted to get his house renovated. Now he is passing his time by involving in the construction work with something he can do. With Squander app, David can participate in cleaning the construction waste from his site that can be detect the waste material and find recycling company location to trash the waste, keeping the environmental at a better place. Minimal viable product. The features are the map integration with nearby recycling factory location, scheduling the pickup of recycling waste by the factory, creation of user profile for each user uses the application, and showing the history of a pickup that is scheduled by a user, and finally showing the recycling statistics for an each user.
Hi guys, let's take a look at the technologies we used in the application. So for the front end, we have Swift and CoreML. So CoreML, we take leverage of the inbuilt machine learning capabilities of iOS devices, and the front end communicates with the back end, which we designed as a Python application, which takes in request and process images for the machine learning libraries and APIs. For the machine learning API, we have Keras, and we use TensorFlow based learning layers. So we have multiple neural networks called the CNN that process the image and identifies the recyclable items in the image. That data gets returned to the Firebase, and then we also have the backend programmed to find recyclable locations that accept the identified items from the image. So what would we respond back to the front end would be a JSON data that has information on what all are the identifiable, what all are the recyclable objects, and which is the nearest recyclable location that they could drop their recyclables off. And for the cloud service provider, we used AWS mostly because we have experience in AWS, and that was the low barrier entry to the cloud platforms. Also, they provided us with some um, amount to get started. We though exhausted all of that. We have also designed something called the infrastructure as a code. So we maintain our the AWS infrastructure as code, and we use something called the CDK, the Cloud Development Kit. That's a kind of a CLI that allows us to execute the CDK supported programs to design to implement the infrastructure in AWS, which was really great, which made us very versatile in making any changes in our architecture. We did not have to go manually change anything. We just have to change something in the code, and then we redeploy the whole stack, and the AWS would respond to that and change our infrastructure, which is really cool. We learned about that participating in an event at the New York. I forgot which place that was. It was something near the Hudson Valley, Jerica Center or something. I forgot. Anyway, so coming back to the architectural diagrams, we have the conceptual diagram. The conceptual diagrams gives you a very high level view of how each of the component in our application works or communicates with each other. So to give the basic idea, it's the mobile app that the user uses to capture the image, and then the image will be sent to the backend, which will be handled by the request handler, and then it process the image and make it consumable for the machine learning model. So the model is designed to have some input parameters which the image has to comply with. So we have this backend that transforms the image in the input layer format that the machine learning model has. And once machine learning library, I mean, sorry, the machine learning model does its thing and finds the identifiable items, we send that data back to the mobile app. But then we also query the map API, which gives us information on what are the coordinates that we have to show the user when they click on the map view. The mobile app then uses this information to display the user what identified items are, and also uses the map API um, to deliver the map view in our application, which I think is really cool. And now this is the overall architecture of our Squander application. We also designed a CI/CD pipeline to automatically deploy any change to the AWS infrastructure. So we have the iOS model there that works on that has a MVC architecture. MVC is a model view controller architecture where we are able to update the um, update the view based on how the user is interacting with the application. So um, when any of the input or user interaction is happening with the application, we register it through the controller, and then the controller sends information to the model to make changes or to ask it to gives the logic to react with the input that the user gave, and then the model would update how what the user views in the screen using the view module. um, and then looking at the from the back end, we have developers committing code changes to GitHub, and GitHub would trigger the GitHub pipeline. We have something called the GitHub actions that get automatically triggered with any code changes in the GitHub repository. That triggers an automated CI/CD pipeline which runs test, build, and test, and that gets delivered to the AWS pipeline, which uses a CDK that we talked about before to deploy the whole infrastructure to AWS. Uh, but the code changes does not result in a whole infrastructure upgrade, but it just result in a minor application change in the infrastructure. So during our development phase, most of that was on iOS, the application, the app, and also on the machine learning model. So we had minor deployments on the app and also on the machine learning model and associated architectures.
Thank you, Austin. Now we'll be talking about our machine learning algorithm. Our algorithm works by taking an image and splitting it up into its pixels and vectorizing them. We then pass these pixels to an input layer of our model. From the input layer, the information gets passed through a series of hidden layers where calculations are being done. Then these calculations get passed to an output layer where we get confidence values for each of our classes. Next, our model can classify images into 6 different classes. The 6 classes are cardboard, glass, metal, paper, plastic, and miscellaneous trash. On the right, you can see some example images on what we use to train the model. For our model evaluation, we can see that the model accuracy is about 75% by looking at our validation accuracy. On the left, you can see an example of our model very confidently classifying this image of a glass bottle as glass. In this graph on the right, we can also see that the model is overfitting. This can be caused by a lack of training data, too many epochs for training, not a good amount of variation in the training set. To combat this problem, we implement transfer learning. By using transfer learning, we can leverage a pre-trained model that is trained on a much larger but different data set to help tune our own custom model. By using transfer learning, we can alleviate the need for having to go back out into the internet and curate a larger data set. The results of transfer learning had a huge improvement. The accuracy improved from 75% to 94%. We can also see that if we stop training around 40 epochs, we will not be overfitting anymore. I will now be talking about our sprint overviews. For Sprint 1, we were mostly setting foundation for the project by discussing ideas and brainstorming, creating team roles, set up meetings, and set up our tools such as GitHub, Jira, and Wiki page. Looking at this burn down chart, we were pretty close to the ideal trend. Next, looking at Sprint 2, we did a lot of research on the technologies needed to develop the application, while developing the base model for our image recognition of trash. In this sprint, we lagged behind a little, but we were able to right the ship and finished our tasks on time. In Sprint 3, we were mainly working on the technical paper. In terms of development for the application, we added the feature to capture and classify an image. We also added the feature to upload images to the application. In this sprint, we were also close to the ideal trend. In Sprint 4, there was a lot of development on the front end side. We developed a large part of our application with the home screen, results screen, capture screen, and processing screen. We can also put the model we also put the model and the application together in this sprint. So we were able to see a lot of the application shape up in this sprint. Other than a small chunk of time, we were slightly behind on progress, but we were generally very close to the ideal trend as well in this sprint. On this slide, we could see the examples of the launch screen, home screen, capture screen developed in Sprint 4, as well as the gallery screen, processing screen, and result screen. For Sprint 5, which was after our break, we did some logistic updates here to our GitHub wiki and technical paper to have a fresh start for the remaining sprints. We also worked on deploying the application to AWS and improving the model accuracy. We also added our contact information to the application. For this sprint, we were actually behind for most of the sprint and didn't end up finishing our tasks. Here you can see what our application looks like where to access the information section. In Sprint 6, we worked on improving the model accuracy and mainly worked on ways to improve the user interface and user experience. In this sprint, we kept on track and stuck close to the ideal trend. In these images, you can see some implementations of improving our UI and UX experience. We mainly wanted to focus on the application displaying information clearly and having the information be more readily available for users. In Sprint 7, we looked to implement some more of the UI UX changes. We did this by adding new features to the navigation bar, adding a frequently asked questions section and changing some views. We also implemented accounts for user profiles to remember certain settings and store personal information. And in these images, you can see the changes we made. We added a login sign up page as well as a feature revolving around that process, such as the reset password page. And you can also see the details on the trash locations and the facts and question section. Next, Austin will be talking about the next sprints.
Hi everyone, let's take a look at the sprint comparison between the sprint 8 deliverables and the sprint 7 deliverables. So in the previous sprint, we mostly worked on the user UI experience and user profiling. So that allowed the users to have a better user experience using our application. And we also did that to onboard one of our personas, David, who was a retiree and would require much minimal interface to easily interact with the application. Another option we had was the user profiling, which allowed the users to have personal information saved in the application so that they could come back and revisit the information they had provided to the application, and that allowed us to help the users not to re-enter things when they required in the steps of requesting and other communication purposes. On the machine learning side, we engineered the machine learning model to increase accuracy in identifying multiple entities to a very considerable level, where we could say that the application can successfully identify multiple entities from a single image. We also included a FAQ screen to allow the customers to get quick answers to frequently asked questions in the application. In Sprint 8, we primarily focused on increasing the user experience with the application and giving them an overview about how their usage of the application was and how much they were able to achieve using our app. So when we also extended our services to allow users to request for a pickup from a recycling company. So now the users have an option to request a recycling company, and the recycling company, if it chooses to do so, could pick up the recyclables from the agreed upon space or location, um, which uh, which we would say would increase the usage of our application. The another story that we worked on in Sprint 8 was to provide the users with the statistics of their recycling activities through the app, which we did in a way to help the users understand how effectively they are utilizing the application and how effectively the app was able to increase their recycling goals. We also added a user feedback that allowed us to get continuous feedbacks on the deliverables that we are doing, and to structure our sprint, to prioritize our sprint task based on the user feedbacks, and to improve our backlogs based on that. We also successfully integrated a newer machine learning model to our application. So previously, we had the application we had was performing good, but not to the mark that we could say that it is a master's level model. But now we have tweaked it in a way, improving the accuracy and also its features of identifying objects in our application. So we were able to successfully integrate the model that we developed into our application and provide a much better service to users and to the recycling companies to identify the number of items and also the category of the item to that allowed us to further identify the recyclable locations and companies that would process these items. Let's take a look at how we have improved from the professor's feedback during our last sprint. In architectural diagram, previously we had a sequence diagram which was modeled as a conceptual diagrams, meaning that we had these components in the diagram that would much better be labeled as conceptual diagram. So we took the design the diagram to a conceptual format where we could see each module of our application and how that's performing in the overall application. So in the burn down chart, we also had some minor um, minor problems with how the chart was drawn. It was percolating. It was due to some issues with the application that we used to generate the chart, that the ideal line was not smooth. But in ideal sprint, the ideal line for burn down charts are supposed to be smooth, but we had tweaked lines. So we updated the application, we made some tweaks, and Agansha was able to provide us with a much more cleaner burn down chart with the ideal smooth line. We also made a mistake in calculating how the average velocity. We did an average of the percentage while we are supposed to do an average of the uh, completed task points throughout the sprint and divided by the number of sprints that we have completed. So we have made those that changes also, and the new average velocity is updated in slide number 48. Here we taking a look at our sprint task and backlogs. Let's start with the product backlog. So here you would be able to see all the sprint tasks that we worked on in a decreasing fashion. So we first showing you the product backlog from sprint 8. We worked on AWS. So this also have both the stories and also the enablers. Um, we have the user stories that we worked on 8. We have the enablers that we worked on 8, and then we also have that from the 7th. And you would also notice that all of them have been completed with the status as done. And going back, this is the task that we handled in the previous sprints, and you would also notice that the status of these are being completed. So we are proud to say that we have captured all our stories and tasks that we set out to do on sprint 8. So let's take a look at the sprint 8. These have the user stories and also the tasks that we were required to complete for the sprint 8. One of them was for some of them are user stories. So one of them is for a John. He wanted to request for a pickup. So we have completed that. That allows John to send a request to the recycling company, and if the company decides to do so, could pick up the trash from John. For David, we provided him with the statistics. David, being a retiree, had more proud was more proud to use our application to see how much he's able to contribute back to the environment using the statistics. And for David also, we added the feedback. So David could give us user feedbacks on how his experience with the application was. And we also worked for the enablers task. We worked on the AWS resources for Squander, which we used to do manually, but we upgraded to using a command line interface that allows us to deploy the infrastructure to AWS, which had low priority because and the impact that it created was low in a shorter period of sense, but it made our application more maintainable from the infrastructure point of view. Um, we also integrated the new machine learning model. We aggregated the GitHub task and other deliverables that we required for completing our sprint course. Let's focus more on the user stories that we worked on. So one of them was, as I mentioned, for John, we included a request to pickup feature that allows him to send requests to the companies to schedule a pickup. We have formatted it in the user story format, the agile user story format, and we have as a John engineer when he wants to request a pickup so that he could get his trash pickup, then trash or recyclables picked up. I would update that. And the acceptance criteria is that he gets a promise that his recyclables will be picked up. We need to update from trash to recyclables there. And for retiree John, we we provided him a feature that allows him to see how his activities using the app was when he clicks on the stats page. And also for David, we allowed a feedback page that allowed him to quickly give us a feedback whenever he wants to, without actually contacting the team. So when he clicks on contact team, he would have a page where he would provide feedback and then submits, which gets sent to us, and we would be able to view that.
Hi, it's me Akanksha Agarwala, and I will be going over the test cases as in this sprint 8, which is also our final sprint. In this, we have completed 3 user stories, and we will be going over the test cases for all the 3 user stories. So, our first user story is about the user feedback, and the story ID is SQD81. So, the first test case is locate the contact team icon on the navigation bar. The expected result is user should be able to locate the contact team icon on the navigation bar, and the test result is user was able to locate the contact team icon on the navigation bar, and the test case is a pass. Then we will be going over the second test case, which is click on the contact team icon, and the expected result is user should be able to see the contact team icon on the nav bar, and it should be clickable, and the test result is the user was able to click the contact team icon, and it was taking them to a new screen, and the test case was passed. Then our third test case is locate the contact team email, and the expected results are user should be able to see the Squander contact team email address on the screen, and the test result was is users were able to see the email address on the screen, and the test case was a pass. Then our next test case is locate the feedback request button. The expected result was should be able to see the user feedback request button, and the test result where the user were able to see the request feedback button, and which was also clickable, and the test case is a pass. Then we will be going over the test case is for our next user story, which is about the recycling statistic, and the user story is ID is SQD76. So our first test case for this is locate the stats icon on the navigation bar, and the user was able to locate the stats icon on the navigation bar, and the test result was user were able to locate the stats icon, and the test case was a pass. Then our second test case is uh, view the stats of the recycle items. The expected results was users should be able to see the statistics of the recycle item on the screen, and the test result was that users were able to see the statistics, and the test case was a pass. Then our next test case is the statistic should have a detailed view like the contact name, date, and the item. And the expected results were user should be able to see the details of the recycling company they have used along with their date, item, etc. And the test results was the user once on the stats screen, the user was able to see the statistics with a detailed view of the company name, the item they have recycled, and along with the date on which they have recycled. And the test case was a pass. Then we will be discussing the test cases for our third user stories, which was the request pickup scheduling, and the user story ID is SQD73. And the first test case for this user story is locate the recycling company detail button. User should be able, expected result is user should be able to see the recycling company detail button, and it should be clickable. The test result was the user were able to see the detail button and which was clickable, and the test case was a pass. The second test case is view the recycling company details, and the test results were the users were able to view the recycling company details, and the test case was a pass again. Then our test case is locate the contact button. User were able to see the contact button and which was should be clickable, and user were able to see the contact button on the details screen and it was clickable, and the test case is a pass. Then the next test case is the contact button should be clickable, and the test results where the contact button was clickable, and when clicked it was taking us to a new request screens, and the test case was a pass. Then the next test case is locate the request screen. The users were able to locate the request stream with the waste images and a little description about it, and the test case was a pass. Next test case is a description box, text box should be visible to the users, and the users were able to see a description text box in which they could enter up to 100 characters, and the test case was pass. Then the next test case is locate the request button, and the results where the users were able to locate the request button on the request screen, and the test case was pass. And the last test case is the request alert should be visible. So that's the test results where once the user clicked on the request button, the request was sent out to the recycling company, and also an alert has been sent to the user stating the same, and the test case was a pass. Then, as I as mentioned before, that in this sprint we have picked the remaining three user stories for our product, and all the remaining three user stories were completed in this sprint. And this is how the sprint 8 burndown chart looks like. The orange is the idle trend, which is and the blue is the remaining effort. As you could see in this sprint, we did a pretty good job. We in the start of the sprint, we were a little behind, not much, but then we catched up pretty well in the middle, and as you could see in the end, we were in fact doing better, and we were having less work than we were doing better, and we could meet all our deadlines. This is the team velocity of Squander. So as you could see, this is the velocity report, and the average velocity of our team is 35, and this is the committed completed ratio. As you could see, starting sprint 1 to 4, we had a committed completed ratio of 100%, but in sprint 5 and sprint 6 we were a little behind in our committed completed ratio. The reason behind it was there was some blockers and issues that came up, but Again, in sprint 7 and sprint 8, we were able to catch up all the remaining effort. And again, here the committed and the completed ratio is 100%. So our average committed completed ratio is 99%, and the current ratio, which is the sprint 8 and the final sprint, is 100%. Now let's see the retrospective, what we have, what as a team we thought went well, needs improvement, and the future action. So as a team, we what went well was the team involvement in the project, and also we kept proper track of the tasks for each member and was communicating with each other to complete it on time. The things that as a team we need improvement was implementing daily scrum principles, and also we felt like we could allocate some time for knowledge sharing about the work that the people are doing. And the future action for this was we will be implementing the daily scrum principles, and also we will be having interactive activities to improve team engagement. Next, Rajat will be presenting.
Hello everyone, my name is Rajat Nagokar and I will be talking about future sprint. So as this is our last sprint, that is a sprint 8, we will try to add more features in the upcoming sprint, such as right now we are able to detect and classify waste into 6 categories such as plastic, glass, metal, and paper. So we will try to add more categories to it so that it detects an object from various categories. So we'll have to implement more classes for recognition and try to build platform application for the app by creating and registering a domain name for the application, and implementing a load balancer and network routing in AWS. And for the last, we'll have one more feature such as develop compatibility across different platforms. Next, project demo. So in this sprint, we have worked on developing a detail screen and a request screen where user can see the details of the recycling locations that when he gets when he clicks a particular recycling location, that he's able to get the address, contact, and the website, as you can see on the left screen, detail screen. Where and the name of the recycling location, that C and K scrap recycling locations. uh, and if a user want to contact this recycling location, then he can press this contact button and he's navigated back to a request screen where a request is set up, and there he will get the image of the item that he want to recycle is displayed there, and below that there is an item, that what item has been recycled is displayed there, and below that he can write a specific description about the item, and mm, he can set up a request so that he can send this request to that recycling location. As we move on, that we have a request, but as you can see, a request button is there in the bottom, that once the request is fully written, and we have all these images and the items, then we can set up the request, and if there if everything is good, then once we press the request button, then a status is displayed that request has been displayed, the request has been sent to the recycling locations. So moving to in this sprint we have developed a stat screen where once the request has been sent to the recycling locations, that is been processed, and we get the details of the history of the recycling, that about what items he has user has recycled along his uh, whole usage of the application. As you can see that the first item that you can see that CNK scrap is a recycling location name, and the recycle item is the paper. He recycle it at on 3rd December 8, 2022. So these are the list of the or history of his usage. And on the right you can see we have a contact team, where if a user want to connect to the contact team, then he can contact this team through this email address and phone number. And below there is a feedback form, where he can write a feedback about how the application is, and what the most important things that he like about the application, and what he can do to develop this application and make it better. So with this he can write a feedback and request a setup. So moving forward is the APIs that we have used in our application, that is MapKit API and Core Location API. So the MapKit API we have used for integrating the maps into the app, and annotating the map with the recycling locations. Uh, and on that map, if for plotting the or getting the current location or something, we have used a core location API for getting the user current location. And so with the help of MapKit and core location API, we are able to see the map, and the plot the annotations and get the user current locations. Next. So next is the GitHub link. So when you click this GitHub link, you will get navigated back to the Squander wiki page, and the final slide is thank you slide. So thank you for watching the presentation.